Okay, so now I've got my calculator, and there's the y equals, so we've gone to the equation editor, and here are the equations. There's y equals 8, and this is that trick I've shown you to graph a vertical line at 15, and there's the vertical line at 5, and then this is the equation right here, x plus y equals, or is less than or equal to 20. I've just subtracted the x, and there's x plus y is greater than 10 it's going to be, and I've again subtracted the x. And then down here the last constraint is just y equals x. Now I graph them as equal signs for clarity, because if I do inequalities it shades in, and it makes there's so much shading it makes it a mess. So if I go to the graph, there it is. Okay, now what we're interested in is this little region here that's bounded by those lines, and sometimes it's difficult to know which side to shade on, and you have to just think it through. You can also go one equation at a time as you're graphing, and then you'll see which one applies to which equation. But we're actually interested in this small region in here, and I'm going to do a zoom box and enlarge that region. So I do zoom box, hit enter, and then I'm going to try to find the corner of my window that I'm interested in. So that's going to be one corner right there. I hit enter, and then I open up the window to the left right there, and then I'm going to open it down and get in all of that feasible region, as it's called, and I enlarge it, and this is the part that I'm most interested in. There's the vertical lines, and they're not absolutely vertical, but they're so close to being vertical that it doesn't show up as a problem here. Alright, so we're interested in this bounded region inside there, and we want to find out the coordinates for each corner. Okay, so we've done that before, where we select the equation, we do second and calc, and we do intersect right there, 5, so I hit 5. And then you see how if I want to find this intersection point right there, I choose this equation right here, and it's asking first curve, but it will show the equation up there, so I know which equation I want. I hit enter. Now I want to do this one, is the one where they add up to be less than 25, or 20 it is. So I just scroll through till I see it, and I'm going to hit the down arrow, and that's not the right equation. I hit the down arrow again, that's not the right equation. There it is. This is the one that is 20 minus x. So I hit enter, and I hit enter again, and there's the intersection point, and I found that it's 12, 8. So I can write down the coordinates there as 12, 8, and then I can find the coordinates for all of these vertices all the way around. Alright, so you pause it and you do that. Okay, well, I have done a quick sketch of this feasible region, and I've labeled all the vertices. It's a little bit easier than looking at it on screen. But what we're going to do then is, since we have as a basic principle the idea that the corners of this feasible region are our points where we are going to find our maximum value, or in some cases we're looking for a minimum value. So if we come back to this equation, we are simply going to plug in our coordinates here for our veterans and our newbies into this equation and work out what each one is. Okay, well, I've zoomed out a little bit just so you can see that by plugging the coordinates in, the 12, the veterans are our x value and the newbies are our 8 value. Plugging in 12 and 8 gives me a fund of $460 that's been raised. If I plug in 15 and 5 right here, I get $475. I plug in 8, 8, I get $360, and 15, 0, I get $375. So I can get the most profit, the maximum amount of funds raised, if I have 15 of my veterans and only 5 newbies, and that is within the boundaries of our constraints. So this one right there is our maximum value. Alright, that's it.